that's negative minus 5. I don't like that. Wait, so when you're doing like when you're doing the bounds, are the bounds from 0 to 2 or whatever like
So
that?
the bounds are where the liquid is.
Oh,
and
okay, so that makes sense. That yeah,
the depth is how far you have to go up and over the trough.
it's like negative. It's like
-5 to -3
for the bounds,
Yes.
and then the road or the distance, the depth is the. Would it just be negative y?
Yeah.
So I figured. The volume is pi squared, so pi. Good choice, Bridget. And then Michael, would you consider? I don't like it. For which one? First one? I got that one.
And then
Can you guys do? You guys use some kind of gigajoules? Okay, I don't know.
It sounds
Just
like
say joules.
just
leave it as
it sounds like there's like all the prefixes. So
No joule.
wait, hold up, I'm almost there. Since it's going.
Yeah.
Oh my, so not 3 million, not like 310,000, not 301,000. Can I see your calculator?
Did you get 1,200,000?
I got that.
That's exactly.
What the heck? Oh, you have to solve for y. That's the part that got me. I forgot, because that's why you want to put on the origin in the first place.
Yeah. So the
Otherwise, it's just like doing that just for no reason.
yes, the equation's ugly if you don't. Darn it! I mean, now I just figured it out. Ready? Or not quite?
Like, not totally.
No, not, what about, we'll do 6 in a sec. What about the D, is that distance or depth?
Yeah.
Depth is for force, distance is for work. So how far do you have to pump slices?
From 5.
5. That bottom one would be 5, but generally you have to pump them to 0. So the distance is 0 upper minus lower y. So the distance is 0 minus y or negative y. Okay, the, sorry, volume. I was thinking force. The volume, it's how wide? 2x wide. I'm going to replace that because I don't have enough room. What about how long? 20. 2 times blank, I'm going to replace that. 20. And how high is each sheet of dy? Okay. I'll replace x in a minute. What are the limits of integration? -5 to -3. Okay, then last but not least, what does x get replaced with?
25 minus.
Square root of 25 minus y squared. You guys are good. Okay, what does that come out to be? 5,120,000 even? Okay. All right, cool. This, I didn't have time to go over it on set 74. It was optimization of profit problem. And so I'm trying to get you a little more practice on that. Here it goes. The hardest part by far is writing the price number equation. Then the calculus is super easy. So check this out. If the price is $5, she sells 48. For every dollar increase in price, she sells 2 less whatevers, widgets. Okay? So we want to do 2 things. I want to write number sold as a function of price. Number depends on price. You get to choose the price. The number you sell depends on that. Then we'll give the revenue equation. So let's start here. What kind of relationship mathematically is this? For every. If you hear for every in life, it says linear. For every is linear. Okay. So if it says for every dollar increase, she sells $2 less, that's a constant linear relationship. Instead of y minus y1 equals m times x minus x1, what are the variables at hand here? Number and price. Which one is the what? Number. So number minus number 1 equals m will come to it, price minus price 1. All right. So what's the slope then? Instead of change in y over change in x, the slope will be change in number over change in price. So for this problem, N1P1 would be the first case. She sells 48 when the price is $5. That's a case we can put in. What about the slope? What's the slope? 2 less, so that's negative 2 for every positive 1. So the slope is negative 2, yay? Yep. So what's an equation then for number slope? Number minus, put everything in.
48.
And minus 48 equals
Negative 2.
negative 2 times the quantity P minus 5, okay? Now, that's the number sold as a function of price. Typically then in an optimization problem, you try and maximize revenue. Revenue is number sold times price. The whole reason you write this relationship is so you can substitute it into your revenue equation. So your revenue equation then would be P times 48 minus 2 times P minus 5. And you can clean that up into the calculus. It's super easy. You could even, it's a parabola, so you could find the maximum without the calculus. Okay, you tracking? All right, try the other two next, please. How are we doing? All right, how are we doing, people? Pretty good, or is it a struggle?
Pretty good.
Okay. While you're checking your answer, it's sometimes the case, weird but true, but sometimes the case If jacking up the price sometimes increases demand, what kind of market would that look like? What kind of market where you jack the price up, people want it more? Just throw something out. Take a guess. It's okay to be wrong. What do you think? You never heard them? So sometimes, if you're shooting for a luxury market, you know, if you make it too cheap, you go, oh, it's cheap. I'm rich. I want something fancy. And so you actually lose sales sometimes if you reduce the price a little bit. You actually sometimes in a luxury market can increase the revenue by jacking up and sales by jacking up the price. All right. So that said, let's talk about position velocity acceleration and such. I know you've done this a lot. And I just want to make sure that, actually, I know you've done a lot of this, but actually there's more. So, and there's also the issue of how do you say it in a calculus way that washes on the AP calculus. All right, so here goes. First of all, I'd remind you that this is not physics class, this is calculus class. I'm not Mr. McKellis. I have a kind of a weaselly little girly voice as opposed to that awesome, booming, manly voice he has. And you should be doing calculus in this class. Okay. So here we go. The AP question, this AP question is calculator active. You may use a calculator. Here it goes. Particle moves along the x-axis. So its velocity is given by that ugly function, units per second. At time equals 0, the particle is at position x equals -1. This velocity function applies from time 0 to time 3, and the units are in seconds. So, if I asked you to find the acceleration of the particle at time 2, that's easy enough. How do I do it? Take the derivative. Now, part of the thing with doing a calculator active problem is what do you have to show? You still have to show things. What do you have to show? You could not just say the acceleration is that without reporting the calculus idea you did. What is the calculus idea? You said is the derivative. So you would have to communicate, hey, person reading this, I use my calculator to calculate the derivative at 2, and then you say, here's my number. And so what is that? To 3 decimals or more. What is that? That's fun. Oh, that's
There's an X in the top right.
this is my right. Gotcha. Right here. All right, so here we go. What did you get there for units? Sorry, answer n units. Excuse me. No, check. Give me a second. Check. I think they have a lot of problems with this, so it might be worth putting it in the function. 0.6 point something 8. Medina, help me out. You're my man. -757. Can I get an amen on that?
I don't think so.
No. Okay, then. That's a no. Medina, you let me down. What else? -8.6. Do we agree with that?
Yes.
Okay, -8.6
What do you
even?
graph?
Or what?
Oh.
0, 0?
0.
0, 1? Round or truncate? No?
Wait,
Yes?
I'm gonna do it.
Okay.
All of them.
Round or truncate, you can drop it at 3 or round to 3. All right. Are you with me so far?
Almost.
What are the units on that?
Units per second.
Units per
Or
units per second, or units per
meters,
second squared, yeah? Okay. Now, this might be the first kind of where we deviate from the physics explanation. When it then asks the second question, is the speed of the particle increasing or decreasing at time 2? First of all, remember speed is what relationship to velocity?
it's like
Absolute value of velocity. In other words, how fast you're changing position without respect to direction. Okay? Removing the sign component to the velocity. You know what I think? Yep. Okay then. Now, typically, when I prove something is increasing in calculus, I prove it's, that's a dot. How do you prove something is increasing in calculus? Its derivative is positive. Now, does that mean then that you have to take the derivative of the absolute value function? Well, thankfully, no. There's a kind of a workaround here. So, I'll come up here, please. Okay, so that's the positive direction, and that's the negative direction. What are you doing? Get out of my face. Okay, so right here. All right. So if she walks in the positive direction, what's her velocity? Did I say walk yet? I said if. I said if. If she walks in the positive direction, what's her velocity? Positive. Okay, so she's going to walk in the positive direction, and I'm going to be the accelerator. Okay, so go ahead. Yeah. Okay. So that case, the velocity was positive, and what direction was the acceleration? Positive. And so what happened to her speed?
Got bigger.
It increased, right? Okay, so come on. This is why I use two. Otherwise, I'm looking at a lawsuit. Okay, so now, if she walks in a positive direction, but I accelerate her or change her velocity in a negative direction, then what happens to her speed? Her speed will decrease. Okay. Now, what if she's walking in a negative direction, and I accelerated her in a negative direction? Her speed increases. Then she walks in a negative direction, but I accelerate her in a positive direction, then her speed decreases. Okay. So then, thank you, Emma. Well done. Give it all in your hand. Whoa, yeah. Okay. So in general, then in calculus, you talk not so much about the derivative of the absolute value, which would make sense. Instead, you talk about how speed or how velocity and acceleration work together or against each other. So if speed is increasing, now when did speed increase in that Emma case? When positive velocity and positive acceleration are negative and negative. So you say that, at least on the AP test, by saying speed is increasing if velocity and acceleration have the same sign, which is to say they work together. Speed is decreasing if velocity and acceleration have opposite signs. Okay? Now then, in this case, they had you find the acceleration at time 2. So I've got that component. But to finish this question, is the speed increasing or decreasing at time 2? What else do I need? I need the velocity at 2. So you need to find the velocity at 2, which is the original function at the derivative of that original function at 2. So I imagine that's something like, 3 sine of 4. So 4 is negative. Sine of 4 is negative. So that should be a negative number. What is it? Negative 270. Okay, and that's units what? All right. So then to answer the question, is the speed of the particle increasing or decreasing at time 2? It's moving left, and it's accelerated left, and so we say the speed is increasing. The speed is increasing because what? Yeah, V of 2 and A of 2 have the
same purple.
same sign. Okay? Is that clear? Okay. Moving on to the second idea here. Find all the times in the open interval where the particle changes directions. I don't know if we actually need to do all this. How would you do that? Do we need to do all that? How would you do it? Changes direction. Given that we have position, maybe you should do that. I think that was the only thing new that I had to hit for sure, but would you do B on your own? I think you should be cool on B on your own. I'm going to put this in my calculator. In the middle of the night, I go walking in my dream. shoot. What was it? Sine of, what was it, t squared? Is that right? Oh, x squared. Okay. All right, sorry. So, what did you say to that? Oh, man. Okay. What does the curve look like here? Like this. So this is position. This is the position function, wasn't it? This, oh, I gave you the velocity. Okay, cool. So then, how do we find when the particle is moving, whatever, changes direction? What did you say? The particle changes direction at what times?
When A of t equals 0.
When A of t equals 0, when V of t changes sign. When V of t changes signs, and this occurs at time equal what so change of signs would correspond to the x-intercepts, right? So when were those? 1.742? 772, thank you. 507? Thank you, and those are seconds. Cool, thank you. All right. You good there? Okay. Find the total distance traveled by the particle. So let's talk, I'm going to minimize this time. I know you guys talked about this last year, but let's go over this. Distance. When I talk distance, do I care if I'm moving right, left, or I just want to know how far you move in any direction?
How far you move.
Okay, so if it's how far I moved in any direction, I want to remove the sign component to the calculation. How do I remove a sign component? Absolute value. So distance then at the end of this story is the integral, the accumulation of many movements of rate times time without respect to sign. So distance is the integral of the absolute value, right? The displacement, that's change in position. I do need to know, did I move right or left? And so what's displacement?
Displacement.
Is the integral or accumulation of, I do want the sign, so I use just the velocity and allow it to be positive and negative to talk about the right left movement. All right, this is another gotcha to the AP calculus test. All right, if they talk about where the velocity is positive on the interval, imagine I had a graph that the velocity was always positive, then from whatever time 0 to time 5, and I threw an integral of this at it. What is it? It's distance and displacement, okay? If the velocity is positive, what's the difference between absolute value and normal v? None, it's the same, right? And so they expect you to actually say that. They're a little picky about that. If the case of the velocity is positive, you'd say this, whatever it is displacement, because it's always displacement, but you would also have to maybe parenthetically say and distance, because velocity is positive on the interval. Okay, and you need to show, I know it's actually both of them, distance and displacement, because it's monodirectional movement, it's the same. All right, so if I wanted the total distance in this case, then what am I going to do? Integrate v or integrate the absolute value of v? Absolute value of v. And so if I do that, what do I get then? And at this point I'm really going to find it. Where is it? Oh, can I, oh yeah, a problem solver, you're smart. Oh, you, I'll tell you what, you kids today. All right, so shift plus, from when to when? I don't even see that.
0 to 2.
Okay. 3. Absolute value, where do you find absolute value on the old calculator? Right there. Whee. Okay, yes, use it. Function, sorry, of x. Over there, eventually. Okay, sorry, I'm so much slower than you. Did you get 4.657? Okay. 4.657, whatever the units are, they're linear distance units. Would you find and interpret the integral from 0 to 2? Yep. Good question. So this Cannon, you guys muffed a question on the final exam that had to do with exactly that. One of the distractors was uses the initial condition and one of them was not. And a lot of people missed it. She said we definitely use both. So good question. When do we use the initial condition? You would use the initial condition when they make a reference to or ask about your position. If they talk about what's the distance, I don't care where I started. I just want to know how far I went. If they ask me what's the displacement again, I don't care where I started. I just know what's my change in position. But if they say, where are you? That's when the initial condition comes in. Okay. Good question. All right. So for 0 to 2, you would say this is approximately 1.632. And would you interpret this? Now, when you interpret an integral, you say what it is with units and when it is with units. So they actually look for 4 things. First, this is actually I should say the displacement of the particle from when to when.
Oh, then it would just be 0.632 because you're taking the initial condition.
Oh, but they didn't say anything about
Oh,
it.
they didn't?
Yeah.
But isn't it when you're taking, like, it's the displacement of the particle?
So your question would be, if I ask where is it at time
okay.
2, then I use the
Okay.
Yeah. So the displacement of the particle from time equals 0 seconds to time equal 2 seconds is 1.632 units. You could say that the particle at time 2, the particle is 1.632 units to the right of where it was at time 0. That would also work. You with me? What about, I know it feels redundant, but there's a difference. There's a point to this. So 0 to 1. What's the answer? 0.520? 420?
Or 540.
540, I'm sorry.
Yeah.
Okay, gotcha. All right. What's same thing? Displacement? It's still no absolute value, so is it still displacement? It is. Okay. This is the displacement of the particle. All that's the same. From time equal 0 seconds to time equal 1 second is 0.54 units, but they will actually be looking for a little more. What else? It's also the distance. Because the velocity is positive on the interval 0 to 1, this is also the distance. The particle travels from 0 to time. Say it again. Well, you should. Before, okay, so that's a great question. If I did this, then I can say the displacement right away. I know that's a thing. But I would then look at the graph, or at least if I had a graph, and see, is it also a distance? So you should always look. Okay? Let's go on. In this case, the function is not easily integrated. That would require some serious series knowledge on your part, which you don't yet have. Write an expression involving integral for position at any time t. If you give me an expression involving an integral for position, that's it. This one asks about position. Well, I need the initial condition. Does that go into position? Yeah, that definitely affects your position. So you're definitely going to need that now. What'd you say? Position at time t is? Starting position
-1
plus change in position.
plus the integral
From when to when?
0 to t
0 to t of
v of x.
v of, okay, now I couldn't use t, and I can't use x, because I already used x. So give me something else. U, W, whatever, okay? Now, if you called the position p or something, then go for it, use x. But definitely never use x or any variable in two fashions. I like that because that looks like Rudy. All right, so during the time interval, what is the greatest distance between the particle and the origin? During the time interval from 0 to 3, what's the greatest distance between particle and the origin? What do you call distance from an object to the origin?
Displacement.
It's not displacement. We call it absolute value. The distance, that is the definition of absolute value. How far a quantity is from the origin. That's what it's defined as. So when I say what's the greatest distance between the particle and the origin, we're looking for the greatest x value, velocity value, acceleration value, time value, what? What would represent the greatest distance from the particle to the origin? The greatest? Come on, people, that's not a hard question. X, velocity, or acceleration? X, the greatest x. The greater the x, now, without respect to sign though. So we want the maximum x without respect to sign. So we want the maximum. That, again, that doesn't mean you need to take the derivative of an absolute value function. All you need to do is do your normal absolute extremal work, but then just take out the sign component, say which is the greatest quantity without respect to sign, right? You guys have those velocity zeros, don't you? So you should, on an AP test, you would definitely read through the whole question to see what did you need to store, so you would know to store them. Let's calculations we had to do. How we doing? So this is about the work they'd expect you to see on the AP test. They don't grade for the EVT, but I can tell you in college, and at least one of the professors I had would, you start off in the extreme value problem by saying the absolute max can only be at these places, so that's why I'm going to look there. And you proceed on. Also make sure, as much as it's a calculator exercise, you need to communicate where your critical numbers came from. So make sure in your work you say velocity is 0 at time blah 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 blah, even though you're using a calculator to find them. They look for that. You have to say where those numbers came from. After that, you're using the function. We just did a function that gives you position anytime, so I'm just using that function that gets me position anytime. So what do you conclude? What's the greatest distance after you find the evidence? What's the greatest distance? The max distance is what? 0.8. Feels like that's bigger than that. Okay, remember, it's without respect to sign. So what candidate has the greatest absolute value? Hello? I guess I feel like I should be doing this for you on the calculator. Is this not going well, or are you just being quiet? Tom, talk to me, my friend. Okay, what did you say? What was your greatest candidate? Oh, darn it. Somebody who's picked it. Is this everybody's just what? Yes. 1.772? Okay. That's the time. What is the x value out of? 0.895 is that candidate. Okay. Now then, and then these are smaller than that, I guess? So now the question is, where are you farthest from the origin? At -1, how far are you from the origin? 1 unit. At 0.87, 895, and all those, how far are you from the origin? 0.895. So what's the maximum distance from the origin? 1. Okay, so you'd say the maximum distance from the origin is 1 because it is the greatest absolute value of the candidates. Okay, or the greatest value without respect to sign of the candidates, or something like that. You follow? Okay. When is the particle moving toward the origin? So think about that. How would you go about that? Let's just talk about this together. Moving towards the origin, what would have to happen? Just throw something out. Okay, so there you go. He absolutely nailed it, because you cannot just talk about velocity, because if your velocity is positive, could you be moving away from the origin? When? When you have positive position and your velocity is positive, you're going to be going away from the origin. But if your position is negative and your velocity is positive, you're going to be moving toward the origin, right? So it's all about both position and velocity, so you would need to find both. And compare the signs. So you need, if it's moving toward the origin, would that be same sign or different sign? You said it, let's say it again. Different sign, okay? This would have to be when velocity and position have different signs. Then you would have to actually look at the graph of each and compare, or I guess you could do it analytically. How do you graph the x function? Will your calculator graph an integral defined function?
No.
It won't? I thought it would.
No.
It doesn't?
I don't think so.
The devil, you say.
And on the note sheet, you did change it to like, it does say if is it moving towards the origin at 2.6.
Oh, I
Which would
did.
be like a lot easier than.
Oh, yeah, because that
It's like that.
everywhere would be considerably harder. And on the AP test, it usually says that in instant. Okay, so on your notes it says at 2.6.
Yeah.
All right, so thank you. So velocity at 2.6, you'd find it and look at the sign. The position at 2.6, you'd find it, look at the sign, and then you'd answer based on how the signs compared at that instant, right? Okay. How about the last? Is that the last one? Now this is not typical of an AP question. They would usually have, 3 or 4 parts, and I'm just trying to throw everything possible at you. How many times at the origin? Do we have time for this? Probably not. Okay. So we'll go over tomorrow. Tomorrow there'll be no homework, so this homework is actually due. Yeah, it's due tomorrow. Yeah, it's due today. Have a good day.
Part I, the intermediate value.
Yes, yes. So you'd find it at its extreme points. So you'd be able to see it in your heart.
Thank you for telling me.
You weren't here to hear it.
Yeah, I
Did
know.
they play the game?
No, but I heard it. I was wondering if I get a letter for I've been debating, but
Yeah. Normally I would have said either I just had because you I was actively learning.
awesome. Thank you so much.
Let me I'm thinking about changing to Ms. Cannon's questionnaire though, so I'll get you the questionnaire I want you to fill
Okay.
out.
Do you want me to also do the one that's on like the counselor page?
Have you already done that?
I kind of have it mostly filled out for like I did it in physics, so I can just.
That one are like the same except for like.
I haven't done Canon's yet, so
Okay. Just do the one you're already doing, because Ms. Cannon's is really good, but you've already done one.
I don't have any for math yet. I just want for physics that I've done so I'd have to change some of it. So if you have one that you specifically like, I can definitely do that.
The same one as the counselor.
Okay, cool. Awesome. Thank you so much.
You're welcome. Have a good day. Oops, I forgot to stop this recording. Welcome. Have a